Okay. In this video, we will explain about the memory system. How a processor will interact with the memory system. So, this is our interaction diagram, and we have this is our processor, and this is our memory system. This is our memory system. Then two important registers associated with the memory interaction are, one is MAR, that is our memory address register. Then another register is MDR, that is memory data register. Then there will be a address bus. This is our address bus. This is our address bus. Then there will be another bus called data bus. This is our data bus. Then one more bus is this control bus. Then okay, this is our memory. Assume that this address bus is k bit address bus. Then by using this k bit address, or we can say that processor will generate a k bit address, and by using this k bit address, this processor can access up to 2 to the power k. 2 to the power k memory locations. Processor can access up to 2 to the power k memory location, or we will call this space as the from 0 to 2 to the power 0 to 2 to the power k minus 1 as the address space corresponding to the processor. That much memory locations can be accessed by the processor by using this address bus. Then another lines are data bus. This data bus will be used to exchange data between memory and a processor. So whenever we will place an address on the address bus, first processor that will place into memory address register, then that address will reach through the address bus, that will be received by the memory. Then memory system will read the data from the corresponding location. That will take some clock cycle. Then after reading that data will be placed on the data bus. At the same time, an MFC signal will be sent through the control bus, so that the processor will identify that okay, data is available on the data bus, and that will be captured into the MDR. And from MDR, processor can use that data for different purposes. That's about the read operation. Similarly, in the case of write operation, the address will be placed in the MAR register, that will be available through the address bus, that will reach into the memory system. Then memory will enable the corresponding memory system. Then data will be placed in the memory data register, that will goes through the data bus, and that will reach into the memory system. And write signal will be issued on the control bus, so the data will be written on the memory system, or returned to the memory system. Okay. Then assume that this is an n bit wide memory, so the data read will be n bits, and that will be passed through the data bus. So this is about the how the processor is interconnected with the memory. Okay.
The maximum size of memory
that can be used in any computer is determined by the addressing scheme. 16-bit computer that generates 16-bit address is capable of addressing up to 2 to the power 16, that is 64K memory location. Similarly, machines whose instructions generate 32-bit addresses can utilize a memory that contains up to 2 to the power 32, that is equal to 4G memory locations. And this is the connection of the memory to the processor we already discussed. Next is another concept is word length. The number of bits actually stored or retrieved in one memory access, that can be referred to as word length. Normally the width of the data bus in the case of processor will be same as the word length. Then another concept is memory access time. The time that elapses between the initiation of an operation and completion of that operation, that will constitute the memory access time. For example, in the case of a read operation, the read request is first sent, and the time between that request and the MFC signal received from the memory system. Memory cycle time. The minimum time delay required between the initiation of two successive memory operations. For example, the time between one read operation and next write operation, or between one read operation and next read operation, like that. Normally this time will be slightly longer than the memory access time. Okay. And next is random access memory. What is the meaning of random access memory? A memory unit is called random access memory, RAM, if any location can be accessed for a read or write operation in some fixed amount of time, that is independent of the location's address. Another type of memory is sequential access memory. In that case, the memory, the time required to read or write depend on the address or position of the memory, position of the data we are accessing, and also current location, currently where we are located. But in the case of random access memory, the time required will be a fixed amount irrespective of the location's address. Next we can discuss about semiconductor memories. Semiconductor memories can be classified into volatile memories and non-volatile memories. So in the case of volatile memories, as the name implies, they are volatile, means they will retain their data as long as the power is there. When the power is lost or power is interrupted, the contents may be lost. So under this category we will discuss DRAM, dynamic RAM and static RAM. And another type of memory is non-volatile memories. As the name implies, they will retain their contents even if the power is lost. That is non-volatile memories. And under these non-volatile memories, we have ROM, PROM, EPROM, EEPROM and flash memory. And we will discuss each of these memories in the coming videos. Okay. Next we have to discuss about the internal organization of memory chips. Memory cells are usually organized in the form of an array. Each cell is capable of storing one bit of information. Each row of cells constitute a memory word. Okay. Next we can consider about the organization of bit cells in a memory chip. So this is the address decoder. address decoder. This is the address decoder, and this is the one of the important component within the memory chip. And the input to this address decoder are address lines. In this example, we are considering, we assume that our address bus is only for this. That is, these are the address lines A0, A1, A2 and A3. These are our address lines. Then the output of the decoder will be, we have we have a set of lines, output lines. We can represent them as W0, W1 and W15. We will have 16 output line corresponding to the 4 address lines. Then these lines are called as, these are known as word lines. We will call these lines as word lines. We will call these lines as word lines. And these lines are used to activate one row within the memory chip. Okay, we will explain that later. Then there will be a number of memory cells. This is one memory cell, another memory cell. Okay. And these are the memory cells in this our memory chip, and these memory cells will be connected with the word lines. Example, in this case, these memory cells in the first row of the memory cells in the first row will be connected with the first word line. Similarly, here also, this is our memory cells that can store one bit of information, and these cells are connected with the word lines. Here also we will have a number of such cells. Then here also these are our memory cells, and all these cells are connected with the corresponding word line. The first row, the memory cells on the first row is connected with the word line 0. Then these are connected with the word line 1, and these are connected with the last one, the last word line, that is word line 50. So whenever these word lines will become active, then the corresponding bit cells, the bit cells connected to that word line will become activated, and the contents on that bit cell can be contents on the memory cells can be read. And as we know, the address decoder, this is actually a decoder based on the input lines, value on the input lines. Any one of the word line will be activated, and corresponding row will be selected or activated, and the content can be read. Then another feature is these word lines are okay. The content from these cells, memory cells or bit cells will be read through another line. This line. This line is called a bit line. So the B value, the value present within the memory cells will be available through the bit line, and the complement of that value, B bar, whatever the content, that complement will be available through another line, is B bar. And these lines we will call as bit lines. Bit lines. That is bit line and bit line bar or complement. That through that lines we can read the content of the memory cells. Similarly, here also so this cell will be connected with this one and this one. Here also this will form the B and B complement. This also bit lines. And another set of bit lines. Okay. These are another set of bit lines. This is B complement and B. Okay. In our diagram, we'll assume that in each row we have 8 pixels. Just we are assuming that. So this is B0 bar, B0, B1, and this is B7. 8 we can store 8 bits in a single row. Correspondingly here also. Then another component present is okay. Then how the data present within the memory will be able. For example, if we are giving an address through the address line 1 0 0 1 0. This one is given through the address line. That is 0 1 0 0 is supplied. Then the address decoder will decode this address, and based on that, okay, we are assuming that this is not like that. 0 0 1. We are issuing 0 0 1. Okay. Then the decoder will decode this address and then enable the corresponding word line. In this example, this line will be enabled. Word line 1 will be enabled. So the enable means that will become active. That is working of the decoder. So this line will be active, and these cells, this one, this one, this one, all the cells connected within that word line will be activated. So the content present within these cells will be available through the bit lines. That row will be available here. The content of the entire row will be available through the bit lines. That's about how to read the content. Then another feature is at the bottom of the or at the end of the bit line we will have another circuit called that is called sense write circuit. Sense write circuit. We will have another circuit, sense write circuit, in all these cases. At the sense write circuit. Here also we will have sense write circuit. And the purpose of the sense write circuits are to sense the data through the bit line. Normally, the content of the voltage or current levels within the bit cells will be very minute or small voltage. So, the sense circuit that will sense the content and then make some amplification. So, we will call this as a sense amplifier also. Amplifier. We will call the sense right circuit as sense amplifier also. Then the sense circuit will sense the content of the bit line. Then based on that will give that content through the data lines. These are connected to the data input output lines of the chip. These are the data input output lines of the chip. So the sense right circuit will sense the content of the bit lines and that value will be given to the IO lines. Or in the case of a write operation, the value present on the data IO lines will be received by the sense right circuit and that value will be placed on the bit lines. So in the case of write operation, what will happen is we will issue the address through the address line, then the corresponding line will be selected. For example, we are trying to write some data to the same address 0001. So first we will issue the address here. So this word line will be activated. Only this word line will be activated. Then next is this data will be available through the data lines that will first reach into the sense right circuit. The data will be kept here and that the data and its complement will be available through these bit lines and that will reach to all the cells within this column. But only this one is activated. So that will reach here also. Similarly here. And that content will be uploaded or that content will be placed into these cells. Or that the data present within the data lines will be returned to this row. That is the how a write operation will be performed. So this is the organization of the bit cell within a memory chip. Okay, this memory chip or this memory organization can store 128 bits. 128 bits can be stored in this memory. Here we have data lines D0, D1 up to D7. We have 8 data lines. And this organization we will call as a 16 into 8. 16 into 8 organization of 128-bit memory chip. So total capacity is 128 bit and we have organized this memory into as 16 into 8 memory because we have 8 data lines. Okay.